Yeah.
Okay, folks. Let's see why this works. 8 times 8.
64.
8 times minus 3i.
Negative 24i.
Positive 24i.
And then that's positive 24i.
So they cancel out.
Good,
And then you
9i
get negative.
squared.
Minus, yes. Good job. And that I squared becomes,
A positive 9.
so 64 plus 9,
Equal to 73.
73. It's amazing how that works.
I don't believe it.
So, more importantly, does this work that way every time with conjugates?
I'm assuming not.
Yes.
Well, let's find out.
Until I get my elementary.
That makes too much sense.
So if I have a number that's a plus bi, hang in there, times its conjugate of a minus bi, would you agree that those two represent conjugates?
Correct. Yes.
So let's multiply them out. A times a is a squared, correct?
A squared minus b. Yes.
This is minus abi,
Plus b.
and that's plus abi. And then this is minus b squared I squared.
Okay, so the middle portion would just keep.
Can you scroll up?
Middle portion adds out. And we have a squared. Now this I squared turns that into a plus b squared.
Yeah.
So if I had two values that are conjugates, if I want to be able to quickly multiply them together, I just take the number part of it, a squared, plus the number part of it, b squared, and add them together.
So if you have two conjugates, you take the number part.
So let's look. What's 8 squared?
64.
What's 3 squared?
9.
I ended up with 64 plus 9. That is 73.
Okay, can you repeat what you said? You said if you have two conjugates, take number part and
Squared, and add it to the other number part squared. And that gives you your product.
256.
Questions about that? How many of you have ever seen that before?
Never.
Not very many.
I've ever seen it or
Have ever seen that thing right there before?
Yeah, last year.
Last year? Good. You saw it last year. Did you remember it?
didn't see that exact.
When we started doing it, yes.
Okay. All right. We have division left and then solutions left. We're getting close.
And then lunch.
Then the fun stuff.
Lunch.
Hopefully our homework.
Yeah.
Favorite. I love homework.
So let's look at division.
No.
5 minus 2i divided by 3 plus 4i. Now, go back to the original definition of I. What does I represent? So being the good mathematicians that we are, we know that we cannot leave a square root value in our denominator. Is that correct?
correct.
So we will be adjusting this
Should.
because we're going to multiply the numerator and denominator by the conjugate of which one? The denominator. We're multiplying by 3 minus 4i over 3 minus 4i. Okay. Do you want to multiply at the top or the bottom?
Let's go bottom first.
Well, I started from the bottom.
All right. I'll do the top one.
Bottom.
That's terrible.
Yeah, I had no idea.
That was terrible. I'll try this again.
I wish I could extend the page on the opposite side.
I used to be able to.
What happened? Did you get it
Change the
updated?
program. Yeah. All right. What's your denominator?
25.
And I'm assuming you did 3 squared plus 4 squared? Good job.
Can't you extend the page on the left? You
I
can?
used to be able to.
So now I've got 15 minus 8 minus 26i. All divided by 25. Do you agree?
Yes.
And so 15 minus 8 is? And 26 over 25 becomes minus 26 over 25 times I. And when we write this fraction in standard form, we need to make it look as two separate pieces to the fraction, where it's the real part and then the fraction part times the I separate. That's how I expect to see those in standard form. Do we have a question?
Read one more example.
Yeah, that would be lovely.
You want to do another example?
So we put the I like separate from the fraction
Yes.
instead of having the I and
Yeah.
Okay.
Alright. Let's try one more. 7 plus 2i over 3 minus 4i.
You can have a negative number.
Can't have an I in the denominator.
Okay, you can have
So what happens?
multiply by the conjugate.
Which is?
3 plus 4i.
Imagine that number. I bet that denominator is the same.
Yep.
So why don't you multiply out the numerator this time? Got a lot of the same numbers, apparently.
Yeah.
I end up with 21 plus 28i plus 6i plus 8i squared over 25. Now we got to collect like terms. 21 take away 8 plus 34i, all divided by 25.
13 over 25.
13 25ths plus... Now, several of you have a little piece of technology sitting in front of you.
What would we call a calculator?
And that little piece of technology allows you to actually do complex number work on it as long as you tell it to. Here's some ground rules on this thing, guys. Did you notice that addition and subtraction really weren't that hard?
Yeah.
No, they weren't.
No.
So I'm expecting you to perform addition and subtraction problems without using the calculator. Multiplication actually weren't that bad either. I'm expecting you to perform those without using the calculator.
Just like having the i's equal.
But division.
Division, on the other hand, is a little more challenging, and so we may find advantages to using our calculators. On the Texas Instruments versions, you need to hit the mode key because we want to be in complex number mode. You go down, most of the way down the first screen, and it says A plus BI. You arrow over there, and you hit enter, and you highlight that. So that tells you that you're in complex number mode.
Wait, I'm already there. How?
What happens if we go to RE?
That is a different kind of mode, and you do not want to operate in that mode yet because you don't understand what that mode tells you.
It looks fun.
It is fun. I enjoy that mode, but you guys aren't going to use it.
I started that mode.
Oh, is that saying that? Never mind.
Okay. Once you hit and select A plus BI and then quit that mode, let's try this same problem right here in our calculators and see if we get to the same answer. So the way we set this up is you want to set a parenthesis 7 plus 2i parenthesis. By the way, the I believe on most of those is the second feature of the decimal point. You have to look at what you mean.
So if we did enter and 7
Okay. So once you type in this in parentheses, divide, put this in parentheses. You do not need to include this second piece. It does it for you automatically.
What's it?
The conjugate part.
If you know how to use it.
Yes, sir.
How do we get the decimals to fractions?
Hit the math key.
And then hit enter.
Enter twice.
With the arrow key. Very first.
Hey, I got
And
it.
then move.
Wow. How nifty. I never knew that.
Oh, we learn something every day. That's good. So, hey guys, eyes up here.
Oh, yeah.
So, does this mean that we have a second way of checking our work when we're dividing?
Yes. Just means we don't have to show our work.
Well, maybe.
Too bad Mr.